Let us begin with the simplest type of pulley, the single fixed pulley. In this arrangement, the pulley is fixed to a rigid support and the rope passes over it. Effort is applied on one end of the rope while the load is attached to the other. Its main function is to change the direction of effort. In other words, we pull downwards in order to lift the load upwards. Single fixed pulleys are commonly used in wells, flagpoles, and hoists for convenience. Now let us understand the principle of a single fixed pulley. A fixed pulley works on the principle of force transmission through the rope. The effort applied at one end is transmitted to the load at the other end. If we assume the rope is weightless and inextensible, then the tension is the same throughout. This means that the effort required is equal to the load, neglecting friction. The relation of work is given as follows: work input equals effort multiplied by effort distance. Work output equals load multiplied by load distance. Mechanical advantage, or MA, is defined as the ratio of load to effort. The formula is MA equals load divided by effort. For an ideal single fixed pulley without friction, the load is equal to the effort. Therefore, MA equals 1. This indicates that the pulley does not multiply force, it only changes its direction. In real life, due to friction, the mechanical advantage is slightly less than 1. For example, to lift a load of 50 newtons, ideally, we must apply 50 newtons of effort. But in practice, the effort required is slightly more. Next, let us define velocity ratio, or VR. Velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. The formula is VR equals d sub E divided by d sub L, where d sub E is the effort distance and d sub L is the load distance. In a single fixed pulley, the effort moves the same distance as the load. Hence, velocity ratio equals 1. This proves that the pulley only changes the direction of force, not its magnitude. For example, if the load is lifted by 1 meter, then the effort must also be pulled down by 1 meter. Now let us discuss efficiency. Efficiency is defined as work output divided by work input multiplied by 100%. Using the relation efficiency equals MA divided by VR multiplied by 100%. For an ideal single fixed pulley, MA equals 1 and VR equals 1. Therefore, efficiency equals 100%. In practice, efficiency is less than 100% due to friction in the axle and stiffness of the rope. For example, if the mechanical advantage is 0.9 and the velocity ratio is 1, then efficiency equals 0.9 divided by 1 multiplied by 100%. That is 90%. Let us solve a problem. A single fixed pulley is used to lift a load of 100 newtons with an effort of 105 newtons. Calculate MA, VR, and efficiency. Step 1. MA equals load divided by effort, which is 100 divided by 105. This gives 0.95. Step 2. For a fixed pulley, VR equals 1. Step 3. Efficiency equals MA divided by VR multiplied by 100%. That is 0.95 divided by 1 multiplied by 100, which equals 95%. Therefore, the pulley has a mechanical advantage of 0.95, velocity ratio of 1, and efficiency of 95%. To summarize, a single fixed pulley is the simplest machine for lifting loads. It does not reduce the effort required, but it makes work easier by changing the direction of effort. In the ideal case, MA equals 1, VR equals 1, and efficiency equals 100%. In practice, friction reduces the values, so mechanical advantage is less than 1 and efficiency is also less than 100%. Common applications include drawing water from wells, raising flags, and operating hoists.